Okay, good morning everyone. Let us start this session with the convex Hulk problem. Now we have seen several of the divide and conquer several problems that can be solved using divide and conquer approach. That is, we have seen binary search, we have seen merge sort, quick sort. We have also talked about the closest pair, which was the geometric problem. Now let us continue and apply the convex Hulk on the which is a, let us try to solve this convex Hulk, which is a geometric problem. Nothing but there's a set of points. This is also a geometric problem like your closest pair. The same way here also we have a set of points, and what convex Hulk means is that if we take the extremes, if we start with the extreme point on a plane, a two-dimensional plane, and then tie, let us take this as the extreme point, and tie a thread around all the points, outer points, then that becomes a convex Hulk. So if you look at this figure, here we have several points, and the extreme points are joined by edges or what, let's say a thread. So all the other points should lie within this loop, and this loop is known as a convex Hulk. Now there are different ways of solving this convex Hulk problem, even different algorithms also of solving this convex Hulk problem. Now let us try to look at the first method of solving this as a brute force approach. Now in the earlier session, the closest pair, obviously there is no brute force for binary search, or there is no brute force for merge sort or quick sort algorithm, because they work the way it is. There are no two thoughts about that, those sorting merge sort or quick sort as well as your binary search. But the earlier problem, closest pair, we have seen that to find which is closest pair, we need to find distance between each pair, and a brute force approach would be to find distance between each pair, so that will be n times, and then for n number of points it will be n square, because considering two for loops and trying to do n number of times finding the distance and which is smallest. That was the brute force approach. Then we have also seen how a divide and conquer approach works by taking a line and dividing 2 points. The same way, even in convex Hulk, we have a brute force approach. What brute force means is, without applying any efficiency or optimization, we just try to randomly search for the solution. So here, let us look at a brute force approach first. Now we have a set of points. Let us say S has A, B, C, D, E, F, G, H, whatever points in two-dimensional plane, what you're seeing. Then a convex Hulk of this would be the pair. We have started from I, if you see. So from I, K, so here we have S of CH. CH is convex Hulk. So SCH is nothing but it's a subset of set S. So SCH is going to have all the points I, K, A, D, C, and B. So this points becomes the convex Hulk. Now let us try to look at the solution for this. To solve this problem, we need to obtain the extreme points, or we can call it a vertices also. And there are two approaches. From one of the extreme points, we can start clockwise or anti-clockwise direction. And it's like a thread. If you take a clockwise direction, take a bigger thread or like a rubber band. If you try to tie that rubber band on outer vertices, whatever those vertices are, those become the convex Hulk, and all the points will lie on the convex Hulk or inside the convex Hulk. So we have two approaches. We can move a clockwise direction, or we can also use counterclockwise direction. Now, to apply a brute force approach, we consider triangles. And triangles means obviously from among all set of n points, we have to take 3 points and join those 3 points. We'll know, it becomes a triangle. So let us look at these three. We can start from any. This is a brute force approach. So we can start from any pair of the any 3 points. So let us assume that we have this point B, H, and I. Now this forms a triangle. Now if a point lies within this triangle, that means that's not an outer point. It's not an outer vertex. It's an inner vertex. So we will check if any point lies inside or outside this triangle. Now, if the point lies inside, then it's not an extreme point. It's not an outer point. Now, this way, we will be able to, obviously, otherwise it's an extreme point. Now, this way we will be able to find. But there is a problem. There is a lot of, though you will get a solution with this, but there is a lot of computational complexity involved. For example, in this case, we have eliminated. Then we will take another set of points. With this point, like I, K, and G, E, F gets eliminated because it's inside. If you take this triangle, H, G, J gets eliminated. And points what are outside, E, F, K, those are outside, C, D, L are outside. So we consider those as extreme points. Now, so this process has to be repeated. And repeatedly we'll try to eliminate. And whatever points comes inside are inner points, and what are outside are considered extreme. And we try to eliminate those extreme points and find the convex set. But the problem here is that doing this approach to finding convex hull, we have to form triangles with n set of points. And possible triangles for n number of points, because there are 3 pairs. So the possibility is n cube is the possible number of triangles that can be formed. So this n possible n cube possible number of among this n cube possible number of triangles, we have to compare for each point whether it lies inside or outside this triangle. So that takes n times. So combined complexity of using a brute force approach, though you don't have an algorithm for a brute force, because what happens is you take simple steps to implement this, which though you get a solution, but it's not an efficient solution. So the complexity of this brute force approach would be O of n power 4, which is very high computational time. So in brute force approach, we try to take triangles and check whether the point lies inside the triangle or outside. If it lies inside, ignore it. If it lies outside, then that may be an extreme point. And the possible triangles are n cube, a number of points n. So to check n number of points, we need to construct n cube triangles. So the complexity of this approach would be O of n power 4. Now, though the syllabus doesn't say that use a divide and conquer approach to solve convex hull, and only says brute force, but let us quickly look at how to apply divide and conquer approach. There are 3 ways. One is to use a quick Hulk algorithm. The other one is gram scan algorithm, though gram scan algorithm doesn't use divide and conquer approach, but it is considered as an efficient algorithm compared to the brute force approach. Then the last one is DC Hulk algorithm. DC Hulk. Now let us look at the quick Hulk algorithm, which uses a divide and conquer approach. Now what happens in quick Hulk algorithm is that we try to choose extreme points. We try to choose extreme points on x-axis, based on x-axis. So which is the extreme point on x-axis? On x-axis we have B, which is the extreme towards the left, and we have another point. Let us call this point B as P1, and we have another point on the extreme right hand, which is K, and let us call this point K as P2. Then there is a segment which is drawn between these two extreme points, that is between P1 and P2. So this is like a line drawn, and then based on this segment, we divide this whole set of points into two sets. One is sometimes called as the upper hull, and the points towards lower end is called as the lower hull. Now, sometimes it is also called as the right hulk and left hulk. So upper hulk is nothing but considered as a left hulk, and lower hulk is considered as the right hulk. Now this hull is the word coming from convex hull. Now when we divide into upper hull and lower hull, first it's like every time we will be taking 2 points and dividing. So let us look at how this is solved. Now we need to find another 2 pair of points in the upper hull as well as lower hull. Now how do we find 2 set of points, 2 extreme points? Like here we have point P1, and we have found P1 and P2, 2 extreme points, using x-axis. In the same way, there is a criteria which we will use to find the extreme points of the upper hull. So what we do is we consider farthest most points from this line or a segment joining P1 and P2. Now H, L, J, E, F, we know they're not farther. There are some other points which are farther. For example, C is farther than these other points. So we try to form a triangle among this. Then we will look at how many points are within or inside this triangle. There are 4 points. Then let us take another farthest point, that is D. And let us try to form a triangle between these 3 points. Now how many points are coming inside? There are 5 points. Now there is another point A. Let us try to form a triangle with this. 4 points are coming. So what we do is we choose the farthest point from this line segment, and that farthest point is nothing but A. Though it looks as the farthest point, it is not in actual geometry if you draw a perpendicular or if you try to take. So we try to select the farthest point which gives us the large area. So whichever point gives us the largest area, that means it is the high possibility that many of the points will come into that largest area. So in this case, if we consider D as a point in the upper hull and join and connect it to line segments which forms a triangle, most of these points are within, 5 points are within this triangle. So these points are inner points. Now what happens is we have taken P1 and P2, and through this line segment we have divided to upper hull and lower hull. The same way now we will take P1 and P2. Now the points which I have darkened it, those are inner points. So they will never be extreme points. So we have to forget about that. Now this P1 and P3, again there is a line segment. We divide that into upper hull and lower hull. Then we try to form a triangle. Now there is only one point here in upper hull. So this is how divide and conquer approach works here. We try to every time divide the a set of points into upper hull and lower hull using 2 extreme points, and this recursively we have to perform this. So there is only one point. Obviously this becomes, there is no points coming inside this. So point C along with B. So the line segment which is, earlier we have taken the extreme points as P1 and P2. So A and K points, those 2 points forms a part of the hull. Then we have found a point D as the extreme and upper hull in the first call. So D also becomes a part of the hull. Now C is there, that's the extreme point. So C also forms a part of the hull. Now we have a segment between point P2 and P3. So we try to consider this A, which is the upper hull, and there are some points in lower hull, and point P5 is the only point there. So we try to connect this and form a triangle, and then this forms, or point A also becomes a part of the a point of the convex hull. Then we have the lower hull. In lower hull, we can take G, but G is not the extreme point. So in the lower hull, we take I as the 6th point, and then try to form a triangle between P1, P2, and P6. Now point G is coming inside, so point G is not the outer extreme point. So that is eliminated, and now we have the convex hull. So this is how quick hull algorithm works, and using divide and conquer approach, and takes the 2 extreme points and divides into 2 halves, and recursively, or repeatedly apply the same procedure and finds the extreme points. So this is how quick hull algorithm works. Let us try to quickly look at the algorithm here. Now here what we have is, we have an algorithm quick hull. X is nothing but set of points. Now we identify 2 points P1 and P2, which is with the smallest x and largest x coordinates. So on the x-axis, the smallest point will be P1, which is the left extreme point, and largest will be P2, which will be the rightmost extreme point. Then P1 and P2 are added to a set convex hull, and let x1 be all the points to the upper segment of P1 and P2, because P1 P2 joins a segment called the upper hull. The same way, all the points below right are forms the lower hull. So that is what I told you. Upper hull, sometimes it is called as the left hull also and right hull also. So that's then recursively we try to call the hull algorithm, passing x1, that is the subset of points which is lying in upper hull, or the left segment, and we will call x2. We call hull algorithm passing x2. X2 is the lower lower hull, or the points with the lower hull, along with P1 and P2, these are the 2 extreme points initially chosen. Now hull algorithm takes 3 parameters, the points which are there in upper or lower hull, P1 and P2 is the segment which divides. So this is actually, here is what is the divide and conquer part. If there are no points in X, then that is, if X is null, then return. You cannot do anything. This part we've found the extreme points. For each P in X, find the farthest point P with largest area. Obviously, largest area means it's assumed that if there are some points, obviously the largest area will cover most of the points inside that. Then add this point P3 to convex hull. It becomes a part of convex hull. Let xk1. Now what we have done is, we had x all points divided into x1, x2, that is upper hull and lower hull. Now passing, if we take upper hull here, we are dividing again upper hull into k1 and k2. That is again upper hull into upper and lower hulls. So if it is x2, we try to this k2, x of k will become x2, and again xk1 and xk2 means we will divide those into, again the lower hull we will divide into upper hull, and again in lower hull. So this is where is the recursive set comes. So all the points to the left are the points to the right. Then pass Now we have P1, P3, P2, P3, because lower hull may have a different set of points which will be extreme, and lower hull will have different ones. So that is why we have considered P1 and P3 will be the upper hull, P2 and P3 will be the lower hull points. So again, recursively calls using statement at 6 and 7. So this is how the quick hull algorithm works. Now, if you look at this two things, just a minute. Now, dividing this to the points left and right is nothing else, will take n times. So creating upper and lower hull is nothing but takes n times. Then, Then when hull is called recursively, what actually happens is for each point in the upper hull, again we are trying to find the farthest point, largest area. That also takes n times. But recursively, when we call hull, this part recursively will give us the the complexity as n square, because it's just like a two for loops recursively trying to solve the same problem. So here, if you see, we have O of n square. So adding these two, we are not multiplying these two. Adding these two becomes, if we add, it becomes a polynomial as n plus n square. So highest degree of the polynomial is n square itself. So the number of points, the time complexity of this quick hull card using a divide and conquer approach is O of n square. And this is in worst case when all the points lies on the extreme. All points lies on the extreme, that is the worst case. On the border, there's no points between or inside the hull. So that's the worst case. So in worst case, quick hull or divide and conquer approach will take O of n square as the time complexity. Now if you remember the brute force method, it takes O of n power 4. And compared to brute force, divide and conquer is much faster because it takes O of n square. So that is what we have all about the convex hull. Though there are gram scan algorithm also, as well as the DC hull algorithm. But these two algorithms and all is not mentioned. Not even the divide and conquer approach is mentioned for convex hull, as well as for your closest pair in your syllabus. But anyway, as for the sake of understanding and knowing how problems are solved, we have covered these two topics.